Hey guys, welcome back to Weld.com. This is part 3 of the CWB, so 3 for the 3GF. So we're going to go into the vertical position today. The notes that I have say that I have to run the square side first. So that's the left-hand side as you guys see it from home. I have to do one start and stop 1.5 inches into the weld plate, and then I can carry on through the rest of the weldment. Second pass that I'm going to do, I have to do a start and stop 1.5 inches from the end. So we're going to go ahead and get into it. I'm going to use my little cheat rod again just to give me a little visible indicator where I need to terminate so I can run my tie-ins exactly where they're supposed to be. Once we get done with this test plate, again, we're going to cut it up and then we'll do our material prep to test it. So we're going to go ahead and bend this plate like we've done the previous two. This one's a little bit different than I'm used to, so we'll see how it turns out. Let's go ahead and start with the root. All right, so again, we're going to be using the ESOB Rebel 235. I'm running about 115 amps. Again, we're using 1/8 inch diameter electrodes. I typically run about 110 amps when I do a single bevel V-groove, but because this is a square and a beveled side, I'm going to try and run as hot as I can. So I'm just going to bump it up about 5 amps. You want to try to run that root as hot as you can stand it, as long as you're able to manipulate the puddle, get that heat up there. I'm also going to have about 20% on my arc force, 25% on my hot start just to get the puddle going. Again, I'm going to utilize my run-on and run-off tabs, use those to my advantage, get that heat built up before I actually enter the weld joint. So let's go ahead and run a root. All right, so I already have my starts and stops laid out. Once again, I'm going to use this little piece of rod as a visual indicator of where I need to terminate. I put it just above where my mark is. That way, when I whip out of that puddle, crater should be about dead center of that mark. These are also hold points, remember? So when you're running this, once you terminate that first pass, you need to call the inspector over. He's going to come over and look at it and say, go ahead, proceed. You'll make your tie-in, finish out the weld root, call him back over. He's going to inspect the tie-in. If everything's clear, you're clear to make the next pass. Again, we're going to have a termination point up here on the right side for the bevel side. He's going to have to come back and inspect it, give you permission to go ahead and run the tie-in. You'll make your tie-in, call him back over. He'll inspect that. If you're clear to proceed, you can do the fill and cap, and he won't need to be back until the piece is capped. I'm using the 1/8 inch 7018-1, the ESOB prime rod. I'm going to point into this groove, or into this corner joint at about a 45-degree angle. My intent is to break the corner down. I guess this is the area where a lot of people get lack of fusion. That's where the separation comes in when you go to do the bend test. You can get a rip in the material right there, so that's why I've bumped my amps up a little bit higher than I'm used to running on this, because I really want to punch into that corner. At this point, we're going to call the inspector over. He's going to come over and look, make sure there's no porosity, make sure you got good fusion, that everything's set up. Make sure you stopped exactly where it's supposed to be on that plate. That's probably the biggest thing that he's looking for. So we're just going to go ahead. I'm going to strike about 3/8 above, dip back into the center of that crater, and just carry on welding like I never stopped. I should be able to run the rest of this in one single pass using my runoff tab. Make sure I get weld metal built up here so that I don't have any low spots when we go to cap. Again, I want a nice uniform bead profile. I mean, we're laying the foundation for our cap with this first pass that we're putting down. All right, so typically when I do my restarts, I start two-handed, and it's like kind of like shooting pool. So I'll put my hand up here, get that arc initiated, and then I'll get this hand out of the way and continue to move up. I do this because I don't want to run the risk of getting anywhere outside of this, causing arc strikes anywhere, and it gives me a little bit better accuracy as to where I'm going to start, a little bit more control. Once that happens, I get this hand out of the way. I prefer to weld with one hand. It was just a way that I was taught, and it served me well when I was doing iron work, because you could actually hold on to the structure with one hand and weld with the other depending on where you're at. So you learn to weld one-handed pretty quick. One of the things I want to pay attention to is that neither one of my leg lengths exceed 5/16 of an inch. I want to try to stack a little bit more metal towards the backing strip, because I want to put some additional metal in between there so I don't have so much I don't have a really big gap when I'm tying in that groove weld. Another thing I want to keep in mind is I can't have any more than a 1/16 of an inch in leg length difference. So I can put an unequal leg length weld in here, but they can't be more than 1/16 of an inch difference. That's some of the things the inspector is going to be looking for when he comes over to check out this root weld. All right, so looks like it punched in pretty good. Got a little bit of undercut right here on the side. I'm not too worried about that because it's going to be in the backing strip. I just don't want to have any undercut on my cap. In here is fine because I'm going to cover that up. I'm going to melt into it. It's just going to go away and disappear. Tie-ins here, looks like it tied in pretty well. As I was watching that weld going through there, I could actually see it punching into the material, so I'm pretty confident I got a good solid bite throughout the entire joint here. I'm going to go ahead and kind of change gears, change a little bit of my work angle. I'm going to hit this side, tie into the bevel. Once again, I need to perform a start and stop here. So I'm going to go ahead and pull out my little cheat rod here. It's not a cheat if it works. Put that in there, just give me a good visual indication of where I need to terminate. Now my goal with this pass was to tie in the beveled side, punch into the backing strip, and then tie into that fillet weld. I really want to punch into that because that's where all the stress is going to be accumulated when we do that root bend. Is down here on the back side where these plates meet the backing strip, because once we remove the backing strip, it's all weld metal and just the edges of these plates getting bent. My technique when I'm running these groove welds is I like to make a very subtle U shape. So all the manipulation comes right here from my wrist. If I try to generate that movement from my elbow, a small amount of movement back here is going to compound and make a large amount of movement up here. I want to be very precise with this. So if I limit the distance to my wrist, it's much smaller moves that I'm able to do. And what that actually does is it allows me to go up to the right-hand side, start cutting out metal, and then come back through and fill it up. Same thing on the left side. As I'm going back through, I'm cutting and filling. We have to maintain a proper travel speed because if we don't, I'm not giving that rod time enough to work. It's doing several things while I'm trying to weld. The weld's cutting out metal, the electrode is melting as well, and then it's solidifying. I have to give it time to do those three tasks. If I go too fast, I'm going to get a high ropey bead profile, and I'm not going to get a good tie-in on either side. That's what I want to avoid. So slow and steady kind of wins the race here. You know, be very methodical, go through it. It may seem like you're moving a little too slow. Let's go ahead and strike this tie-in and go ahead and complete this, and then we'll start developing a plan for our inner passes. So it seemed like the restart was a little sketchy there. I almost lost it, but was able to save her. So here's our tie-in right here. Carried up, got a good even bead profile. Everything's stacked in. Everything's nice and uniform between the root on the square edge and the root on the bevel side. So what I'm going to do now is I'm just going to start putting my inner passes in here. I'll probably put 2, maybe 3 passes in here. It's going to change, and I don't know exactly how I want to do that yet because I have to see the results that I have after each weld. I'm laying the foundation for all my future welds. So I'm right-handed, so I prefer to weld from left to right. I don't like doing a left side, right side, and then one in the middle. It puts a lot of stress on the plates. I'm not a big fan of going right to left if I can avoid it, especially on this bevel here. So I'm gonna go ahead and stack this next one in right on top of that fillet, cover it up. I'll probably be about a 1/16 below the edge of this plate once I'm done. So I may just need one more layer of welds in here before I go to cap, but we'll see. So let's go ahead and fire this one off. Another thing that I see people run into all the time is they get really lumpy welds when they're going vertical. That has a lot to do with feeding the rod into the material. You have to remember that as this rod is melting, it's getting shorter, obviously, very similar to a candle, right? So I have to continue to feed that in there. A lot of people kind of hesitate. They don't feed the rod enough as fast as it's burning, and then what happens is that arc length starts to increase, the voltage is starting to spike, the puddle gets a little bit wider, and you're depositing more weld metal from further away. So now you're building up a lumpy profile, and then you try to overcorrect and cram the rod in there, and then a lot of times that's where you get stuck. I prefer to weld by braille, and what I mean by that is just stay right up close to that material, very tight arc length. I can actually feel the rod getting shorter and digging into the material. That's how I know I'm punching in. All right, so we got this pass in here. I'm gonna go ahead and put my second inner pass in right on the right-hand side. I'm gonna tie this in. Depending on where I can get that bead placement at, I'm thinking about going to cap right after I do this because I'm a 1/16 below the edge of this plate on the left-hand side. If I come up with the same profile over on the right, I'll probably go ahead and go to cap. This is a little bit wider, so I might end up stacking 2 passes in here. I'm just gonna strike it, strike this second pass, see what I have after that, evaluate it, and then we'll go from there. My next course of action, I think I'm going to throw one more on the right-hand side because the left's still a little bit higher, probably because that fillet weld's packed in that corner, and then I still have so much of that groove on the right-hand side because remember, we have a 1/2 inch root in here, so this weld's going to be a little bit wider. So I'm going to go ahead and stack one more on the right-hand side. I'm probably going to plan on doing a start and stop right in the middle because I want to travel just a little bit slower. Therefore, I'm going to deposit a little bit more metal. So I'm just going to go ahead and plan to do a start and stop right here in the center. You want to try and limit your stops and starts. But if I do have to do a stop and start, I want to keep it as far away from these other two as possible. So dead center is right about the mix between the two. That's going to be a face bend in here. So I'm feeling pretty confident about that. We'll go ahead, terminate here, restart, fill that up, and then I should be ready for a cap. Here's my tie-in point. A little closer to the other one that I wanted. Probably should have put that little rod across there to give me a good indication that, hey, there's center, or marked it. But I'm just going to go ahead and perform a tie-in, float this pass in there, terminate this, let the plate cool down for a couple of minutes before I go into my cap. Here's a tie-in, a little higher than I'd like it to be, but I think it'll work out just fine. At this point, I feel pretty confident about going to cap. I'm going to go ahead and let this cool for a minute. Probably might end up putting 4 beads across the top, maybe 3. We'll see how it goes. Let this cool, run that first pass, and see exactly where we're sitting. Plate's cooled down enough. I'm ready to go to cap. I'm going to go ahead and put my first pass right-hand side. Remember, I'm just going to watch the edge of this material. That's where I want the left side of my puddle to flow up against and over, and kind of break down that edge right there, completely solidifying it. All right, looks like we're good here. Don't have any visible undercut. I mean, there might be a little bit, probably less than a 64th, but I did successfully go over that edge, broke it down, tied into it. I'm gonna go ahead and put pass number 2 in here, see what we're left with. Again, I want 50% coverage on the left side of that weld. Just run it straight up the top, see exactly where we're at, and make a plan for the next pass. All right, so that pass went in good. I'm above flush, so that's exactly where I want to be. Pretty sure I'm not over an 1/8 inch, but we'll check that once we're able to get it down and get some tools on it. I'm going to go ahead and make this final pass here. I got a little bit of a groove to fill, so I'm just going to watch my travel speed, keep it a little bit slower, and just make my way towards the top. Again, my objective here is tie 50% into that pass that I just put down and break down the edge of this plate and have a really good tie-in and fusion into that plate. All right, we got the last part of the cap down. Let's go ahead and take the piece down, put some tools on it. If everything's good there, we'll go ahead and mark it out, get it cut up, and get bendy with it. All right, so at this point, I'm looking for undercut, so I just shine a light on here and just check for any shadows. Looks like I've got a little small spot right in here, so we'll check that one. Everything else looks pretty good on that side. This side I don't appear to have, well, there's one spot here. This first spot here, sitting at about a 64th, so we're good. We're allowed to have up to a 32nd. We got one more spot here. And you just point the, make sure your instrument's sitting flat, and then point that sharp point right into the undercut area. Right at between a 64th and a 32nd, so that one's still good. Same thing, I'm a 64th there. So as far as undercut, we're good. Let's go ahead and check cap and make sure we're flush. All right, so let's go ahead and look through the piece. Looks like I've got a low spot right in here in this area, so I want to check my low spots first, make sure I'm at least flush. So again, put the indicator flat and then push this hook down, and right there I'm at 0, so I'm at flush here. We'll check this side right here. Just over flush, not quite a 64th, so I'm good here. Let's go ahead and check our high spots. Okay, so this spot seems to be our highest point, and I'm at a 1/16 of an inch here, so we're doing good. So the highest point of the cap, right at a 1/16. We're gonna pull an 1.5 inch section right here where we had our restart, 1.5 inch section here where we had our restart, and an 1.5 inch from the center. These two pieces where we had our restarts, these are going to be our root bends. This center section is going to be the face bend. Remember, we have a restart here, one right back here on one of the other passes, and then we have one in this area. So we're testing our ability to perform restarts, and 2 roots, 1 face. Let's go ahead and get these cleaned up and prepped. Let's just bend them in order. We'll start off with the bottom root. Again, we're going to put the pressure to the face so that all the force is applied to the root. All right, we have a tiny little indication right here, but it is less than 1/8 of an inch. So that would be a pass. That's the root on the bottom. Don't have any corner cracking, no slag inclusions. Everything looks free and clear. One tiny indication on this one would be a pass. Let's go ahead and move on to the face. So this is the face here. Remember, we had the undercut on either side. Whenever you take this down, you don't want to try to chase out indications. Okay, this was already passed because it met the visual acceptance criteria of the undercut, so I'm not going to chase these out. If I start chasing these out and thinning this material out, I'm not going to be able to bend it. It has to remain 3/8 thickness. So we're going to go ahead and apply the pressure of the plunger to the root to put all the force on the face. All right, so here's our face. No new indications, so that would be a pass. That's our undercut that we had on the face. There's no corner cracking that we have to worry about. No slag inclusions, no separations. This is the undercut, so that material's not ripping. We've just opened that up and exposed it a little bit more. So this would be a pass. Let's go ahead to our last root. Put this one in. Pressure, or the plunger goes to the face. Pressure to the root. All right, root number 2. Have a tiny little indication here and one here. They're both less than 1/8 inch. No corner cracking. No other indications. All right, so we have an 1/8 inch rod. So this is just one way to check it really quick. If I can cover that entire indication up with the diameter of that electrode, it doesn't exceed 1/8 of an inch. So these are pretty tiny. So that is our 3G, 3F test plate for the Canadian Welding Bureau. This would be a pass. Stick around, we got part 4 coming out pretty soon, so make sure you check that out. Make sure you subscribe. Click that little notification button, that way you never miss an episode. If you guys have questions on this, or if you're a Canadian or you've passed the Canadian Welding Bureau test for the S ticket, if you have any tips or pointers for some of the young ladies and gentlemen in the audience that they could do better, some of the things that they want to consider when they're going in to take the test, feel free to share them down there in the comments. As always, we appreciate you watching. Until next time, make every weld better than your last. All right, if you guys are so inclined, you can go ahead and troll me for the exposed undercut down there in the comment section as well. I'm open to it. I can admit when I'm wrong. It's not wrong though. It's good. It's acceptable.